Yeah, first of all, thank you everybody for joining. Welcome to today's webinar. So as you see, today we have a bit of a focus on specifically mapping with the DJI Mini, and I'll tell you a bit about also mapping with other small DJI drones. While some people are still joining, let's get some of the introductions out of the way. Before we begin, the webinar duration will be approximately 1 hour, give or take, I expect. Please, any questions that you might have during the webinar, put them in the Q&A section. I'll have my colleagues here also assisting me and answering some of those that just can be answered through text. And then the others, maybe some more interesting questions, I'll try to then, just pick up and then answer during the webinar. In case you cannot make it until the end, so the recording will be available on YouTube later. But I do suggest you stick around until the end, because at the end we'll have an interesting offer for you that's specifically only will be valid for 24 hours after the webinar. Also, please make sure to join our Facebook group of drone pilots. So on Facebook, you can just search for UgCS users, drone mapping and surveying community, or I think if you also just search for UgCS users, this group should come up. And yeah, so feel free to join any questions you might have later down the road as you're testing out UgCS. So both us and other fellow pilots also will be able to answer there. So for today, what's the agenda? So I want to cover a bit about sort of UgCS for newcomers, because usually on webinars, some people are already familiar with the software and maybe just want to learn a bit more. And also quite a significant part usually are new people, newcomers, so who are maybe not that familiar with what UgCS is yet. So for those of you, don't worry, I will do a bit of an introduction, so what it is, how you can use it, and so on. But with this, I'll try to be quick, because actually the main topic for today, like I mentioned earlier, will be small DJI drones with a bit of a focus on DJI Mini 4 Pro. I'll also explain how you can actually use other small DJI drones like the DJI Air and others through Litchi together with UgCS. And also then we'll do a bit of a workshop on UgCS flight planning. So when we get to the workshop part, until then, actually, so while I'm talking a bit here, if you don't have UgCS on your computer and maybe you want to, maybe you're new to this, you want to kind of try to follow along, you can just head on over to our website, so ugcs.com, and you can actually download it. Just sign up for the free version in case you don't already have it, and then you can just sort of try and follow with me as I will later be showing you different parts of the flight planning and so on. So just a heads up, in case you want to follow along with the workshop, make sure you have UgCS installed. If you don't, that's also fine. If you may be watching from mobile, also you'll just have the webinar recording later, and you can then rewatch some parts when you will want to. Also then later on, I'll try to show a bit of a just like small data sample that we gathered using the Mini 4 Pro drone flown with UgCS. And then also at the end, we'll have a special offer for webinar visitors today. And also we'll have a Q&A where any unanswered questions I'll try to tackle. So let's get started. Okay, so firstly, a bit of a general information about UgCS. So let's start with what is it? So UgCS, it's a desktop-based flight planning software that allows to plan drone missions. That's in simple terms. But in more, going a bit more deeper. So actually, we've been on the market since around 2013. So about 12 years already and counting. UgCS installs locally on the computer, so it's not web browser based. So basically everything installs on your PC or on your Mac. Ubuntu supported also, by the way, for Linux enthusiasts here. So it basically allows you to plan missions starting from more simple to more complex, and also it supports different kinds of drones. So it's one of the few flight planning solutions that actually is more universal. So you maybe are hearing that in some parts of the world or for some projects, DJI drones might not be allowed. So with UgCS, actually, you can control a fleet of different drones. So same platform. You can use Autopilot, PX4, DJI, and other drones from the same flight planning solution. Also, UgCS allows you to plan flights, of course, as you already see probably from the pictures here in full 3D with terrain following, and also even different types of terrain following, very highly adjustable. So all of this we can get into a bit later. So I'll try to take you through what parameters can you change, because there are quite a few, and this gives you quite a lot of flexibility and customizability for your flight plans. Even as you see here, there's the terrain elevation profile, which also just serves as an extra sort of nice addition, allowing you to see exactly where you are, how high are you above the ground, and as you're adjusting the mission, you'll also see a lot of details here. But anyways, time is running, so let's move on. I could talk about this for quite a long time, as you probably gather. So also in GCS, you can plan circle-grammetry missions. This will be one of the topics for today that also I'll be showing. So how can you do this exactly? And this allows you to create oblique, or to create 3D models from oblique imagery. Here's just one example of such a mission. And this is just a short video from actually one of our customers in France that was sent to me and published on YouTube. So this dataset also was gathered over a construction site using circle-grammetry. And this is just a nice flyover, which I think also illustrates quite well how, when you're doing this sort of capture method, how you can capture various different angles. And in the end, even when you have some smaller structures on the ground, how you can very nicely actually stitch this all together. So, and also, of course, like I mentioned earlier, different drones are supported. So something like Mavic 3 Enterprise, DJI Mini, or even larger drones like the M400. So a lot of these, or all of these that I mentioned, can be used with UgCS. So also, of course, you can tackle more large-scale projects. So everything starting from really small sites to larger ones as well. Because here, for example, you can see it's a solar farm that's being scanned, and you can create different routes and a lot of routes in the same mission. Also, for example, what let's say the same DJI doesn't really allow you to do on the Pilot 2 software is you can create different segments together. So, for example, you can have waypoints followed by an area followed by a corridor. So everything is highly customizable, or it can also be simple, whatever you prefer. Also you can use this for corridor mapping, even for LiDAR scans. But again, since this is a more webinar focused more on the smaller drones, I'm just going to sort of mentioning this, but I know some of you also, you might have maybe a smaller drone, and in your fleet, you might also have a larger drone, or maybe you're considering one. So also there's sort of, how to say, room to grow in case you maybe want to expand your fleet. Also, it offers some nice things such as importing map overlays, so you can use your own maps with the software. And also, of course, you can import terrain elevation models, you can import KML files, and even you can create routes automatically from KML or CSV files. So as you see, it offers quite a lot of possibilities, while at the same time still keeping it quite simple and user-friendly. At least that's what we're striving for. Also, you can see, for example, here you can plan missions that are even circular. Also, later I'll show you how you can even do tower scans, which is useful for example, doing telecom tower inspections. And also, one good thing is, so you can use this solution fully offline. So with UgCS, no internet is required. Internet is required initially for activation, for loading all the maps, but it does allow you to cache for offline use both the maps, the elevation. So, and as you can see here in the text as well, it mentions that one area that's cached for offline use can be up to 100 square kilometers in size. And you can have multiple of those. So yeah, you can use this fully offline without any need to have an active internet connection. Also with this, you can do building inspections. And this I think is also maybe quite a good case specifically for the smaller drones, since drones below 250 grams, so 249 grams and less. So in various places around the world, so this is considered a category where you don't really need to have that many, permits if you, in case you want to fly near buildings, do inspections and so on. So also this could be potentially very good sort of direction where to go with this. Also here, it's just a data sample that actually we ourselves gathered. So I flew this drone in Spain. This was the DJI M300 drone that we flew then. And yeah, also this simply using UgCS. You can see we created this mission that allows to scan the facade of this old monastery. And yeah, so then basically after processing all the data, for processing here, you can see I used the reality scan, well, then called the reality capture. Now they're renamed to reality scan. And yeah, you can see the result is quite good, I would say. And this is just from one wall of the facade. Of course, using this method, you can even capture full model from all the sides around. But yeah, vertical inspections is also one thing that can be quite useful. It's quite in demand, I would say, for property inspections, and you can do this with UgCS, as you can see here. Then, of course, you can do also basic photogrammetry and mapping missions. And actually, for today, that's a bit of our focus here, since I know a lot of you guys, who have the mini drones, and maybe you have been using these drones for photos, for videos, and not really for automated missions that much. So for today, I want to kind of show to you a bit, so how can you actually use these smaller drones for those more sort of professional and more higher paying jobs. So now that was kind of it from the intro itself. In case you have some questions about any of this, then yeah, please feel free to leave the questions in the Q&A. Don't put the questions in the chat. That's my one request, just so it's easier for us to track. And then later on, in case you want, we can also get in touch with you and answer. If there's some more complex question that comes up, we can also answer it in more detail. But anyways, let's head on over to the Mini 4 Pro. So Mini 4 Pro, what's happening with this and what can you expect? So it is not out yet, but so next week we plan to release the new version of UgCS, so version 5.14. And with this, by the way, sorry, I see my face is like super lit up from the monitor. I'll try to quickly turn down the monitor brightness a bit, and then we can go on. Okay, I think like this should be better. Yeah. Okay, so what's happening with DJI Mini 4 Pro drone? So it will be supported next week, I expect, with the release of UgCS 5.14. And so what does this mean? This means that for the DJI Mini 4 Pro drone, you will be able to install the UgCS companion app. So if, in case you're not familiar, to be able to connect to the computer where UgCS is running, you typically need to run one of our mobile applications for DJI drones that allows you to connect the drone, and that serves sort of as a bridge between the remote controller and the computer. So you will need UgCS 5.14, you will need your mini drone, and you'll need to install the companion app. I forgot to list the companion app version here, but this will be the new version also, 1.7, so companion 1.7. Yep, so then it'll have full support of telemetry and commands. So this means you'll be able to upload missions to the Mini 4 Pro drone. And also, in case maybe you don't want to pull out the computer when you are in the field, then you'll also be able to simply cache the routes for offline use for this drone within the companion app. And then when you're in the field, you can simply select the route that you want to fly, and you can launch the drone. And in fact, it's also one of the reasons why lately I've been hearing a lot of pilots switching to UgCS, just because of the convenience that you can pre-plan all the routes at your home or at your office, and then when you head out into the field, everything is already prepared. You just take the drone, take the controller, launch it, collect the data, and head back. There's no need to plan missions while you are out in the field. And yep, so also this is supported for all license types. So this includes also the open license or the free license of UgCS. So it's even, like I said, no need to pay. You can just starting from open, but also, of course, then there's Pro, Expert, and Enterprise, which unlock more features. One important note for the Mini 4 Pro drone, though, is that you need to have the DJI RC-N2 or N3. So here in the picture, this is the controller that's on the right side. That's because, unfortunately, DJI has locked down their RC2 controller, which is the one with the screen. So on this controller, you cannot install third-party apps, unfortunately. So yeah, you need to have this controller without the inbuilt screen. You can buy them separately also, by the way, in case you didn't buy it when buying the drone itself. And yeah, then you'll need some Android device to go along with it. This can be some older phone, or maybe you have an Android phone already. So yeah, then you can just install the companion app there, connect it, and everything will work. Then simply I listed here a bit of some steps how to connect. So obviously you need to have UgCS on your computer, PC, Mac, or whatever you have. Then you need to have a mobile Android device that's connected to the DJI RC N2 or N3, whichever you have. You need to ensure that both devices are on the same network, so that meaning that the computer and the Android device are on the same Wi-Fi. Again, when you're out in the field, this doesn't mean you need to have internet on that network, but this just has to be some Wi-Fi network to be able to transfer the routes. When you're using a mobile phone, this can even be the mobile phone's hotspot to which you can then connect from the computer. So it's also one way. And yep, so then essentially once you get both devices on the same network, then the drone and the drone will simply show up on UgCS automatically, and you'll already be able to work with it, upload missions to it, and so on. So I hope this is clear. In case there's some questions, I'll try to answer them in just a bit. But yeah, so quite, I'd say quite simple way. This is more or less the same how you'd be using the drone with something like, with UgCS together with something like a Mavic 3 Enterprise, except that for that drone, you would be using the inbuilt screen in the controller. But in this case, you simply download the app from our website, ugcs.com, downloads, and there's the companion app, and you will be able to use it. So then, in case, like I said, in case there will be some questions, I can come back to it a bit later. But yeah, so now next section is I'll just, in case you don't have the Mini 4 Pro drone, maybe you have one of the other DJI small drones, then also there is actually a way how you can use it on automated missions with UgCS. And I'll try to explain a bit about how this usually works. So this can work through kind of using UgCS together with Litchi, which I'm sure many of you are probably also familiar with. So these are the current drones that, these are the current drones that are supported through the Litchi app. So this is Mini 4 Pro, Mini 3 Pro. For Mini 4 Pro, of course, there will be the companion app, which is a bit more convenient, I would say. Then Mini 2, Air 2S, Mini SE, Mavic Mini, Mavic Air, 2 Mavic Air, and Pro, and DJI Spark. We have already been getting some questions about, since as you probably know, so DJI recently released the Mini 5 Pro drone, but this is not yet, at least in the public documentation, it's not yet available in the DJI SDK. So in case you had the question about Mini 5 Pro, so we need to wait a bit until this gets added, and then probably we will try to add it also to UgCS. But yeah, so the instructions are here on how to use this. And actually, I think I'll stop the screen share for just a second with you. And I'll try to maybe just open up the site, because I think it will be a bit easier if I show you those instructions. I just decided not to kind of copy them in the presentation, because this way it will be slightly easier. But anyway, so here are the instructions on how to use this. If you go to our site, that's manuals.ugcs.com, and then you find here on the side in quick start, so using DJI Mini with UgCS, then this will give you the instructions on how to use it with the Litchi app. And again, that's if you don't have the Mini 4 Pro, you have some other smaller drone that is from this list. So then these instructions apply to you and you can use this. So again, for most of these drones, you will need to have a controller that supports third-party apps. So again, something like the N2, N3, and since there's quite a few drones, I think for some of them, maybe even there was the inbuilt screen supported the apps, but it will depend on what drone you have. And yeah, so essentially, what's the process? So you will need to have the Litchi mobile app. Heads up, it will cost around like $20 or $25 is the like one-time fee for the Litchi app. And yeah, so then basically once you have that, then you can already also actually plan missions for it in the Litchi mission hub. But the missions you plan there, it's just basic putting waypoints there. But so then what you do to get it to work with UgCS. So firstly, you will need to have that drone's profile inside of UgCS. We don't yet have them by default, but you can actually download them from here. So go to this drone and payload profiles on this site, then just find the drone that you want to use, or I mean, obviously the drone that you have. It will download the profile file, so that profile, and then inside of UgCS, you will be able to import it through the main menu. So you'll simply have the correct camera settings just to ensure that all the overlaps will be calculated correctly when you do things like mapping, photogrammetry, and so on. So then once you have that, you will be able to import it, as you can see already here in the picture. And then let's say you plan some route for that drone inside of UgCS. The next, once the route is planned, then you'll go and you will click here on export, and you'll export this route into KML format. You'll need to select altitude relative to ground under the first waypoint, and the format to select, you'll need to select place marks format for all of this to work correctly. And then next in the browser, you'll have the Litchi mission hub open. And then here you can create a new mission and you can import from this KML file. Then you'll have this already, the mission that you planned inside of UgCS here. So you'll already see this mission here inside of Litchi mission hub. You can change then some parameters that you might need, such as the camera capture interval to make sure it matches, heading, and so on. And also the camera tilt you can add at the very beginning, just to ensure the camera will be tilted at the correct angle. And yeah, then essentially you just save the mission, and already you will have that mission from the mission hub automatically available on the Litchi app. And yeah, then essentially you just go, you select that route that you planned in GCS, you select it in Litchi, and you can launch the drone. So it's not as simple as using the companion app where you can directly connect the drone to GCS and use it. But this method, it still allows you to plan automated missions and use them. And by the way, so here you can see this is a very basic example of what mission can you fly with this. So just a very basic mapping mission. But you can actually do obviously more complex missions with this as well. So even let's say if you wanted to do, let's say a vertical facade mapping mission or facade inspection mission with one of your small DJI drones, also same process you can do. You can plan the mission inside of UgCS, export the KML, open from Litchi, and you can run it. So yeah, it's also possible and also something that you can do. Yep, now I think we can go back to the presentation here. I'll try to continue. But actually, I think now we'll, in just in a moment, we'll jump on over to GCS and I'll try to show you some parts of the flight planning. Yeah, well, here also I summarized a bit the Litchi instructions. So yeah, ensure you have compatible drone and RC combo. Install the Litchi app that's compatible, depending on whether you have a newer drone or an older one. The app that you'll need to use will differ. Then you plan flight in GCS. You export the route from GCS into a into a KML file. Open up Litchi Mission Hub, save it, and fly. So in case there'll be some questions, I'll get to them a bit later, probably in the Q&A section. But yeah, so essentially those are sort of the basic steps on how you can connect these drones and how you can use them. And now I think we can probably jump on over into a bit more interesting part, which is the actual flight planning workshop. So let's actually, there's basically kind of three larger topics that I want to cover in terms of flight planning. So first I want to show you how you can plan some very basic mission with terrain following. Then next, how to plan a mission with for already photogrammetry and even circle-grammetry. And then sort of as the third step, I want to also show a bit of the vertical facade capture or tower inspections that you can do with UgCS. And after that, I'll show you a data sample. And then we have, like I mentioned earlier, the special offer for today's webinar. So okay, let's get started. So in case you're not familiar with the UgCS, so I'll try to kind of talk on a level that's understandable for both more experienced people and maybe newcomers here. So here we have our basic mission in UgCS if you want to create a new mission, you can go here on these three, wait, I'll check, yeah. I hope the screen sharing is moving at an okay pace and you can see everything nicely. So we can go here and then can select create new mission. And then we can click on create a new route over here. And we can create a new route from scratch in this case. So then let's simply click on next. And then also we can choose what drone we want to use. So in this case, let's select the, oh, actually, yeah. So this is not the developer version. I installed today the public version. So the Mini 4 Pro profile is not yet available in this one. So it will be available in the next one. But I'll show on the Mavic 3 Enterprise profile, and it will essentially not really change anything. It's more or less the same process. So Then let's go next. Here on the screen, you can select what route type you want to do. And if you don't want to, if you're maybe confused, don't want to select anything, you can also just close this window. But I will select photogrammetry, and then you can choose whether you want to plan an area mission or a corridor mission. And in this case, let's maybe try to do a basic area. But actually, maybe let's do this. So since I want, yeah, actually, let's plan photogrammetry at the very beginning. I think it's one of the more simple ones. So now you can see it prompts you to select the area that you want to fly over, and then simply holding down the shift button, you can mark out very simple, very basic area that you want to fly over. And then you can hit enter to complete this figure. And in case you want to do some more adjustments later on, you can always do that. So you can simply take any of these points and you can make any custom shape for your area that you want. And now I think it maybe makes sense to go a bit through the flight planning parameters. So the ones that I usually change and or suggest taking a look at. So firstly, there's the camera. So for the mini drone, you'll have only one option for the camera. For the Mavic 3 Enterprise, you can see there's the wide and there's the zoom camera as well. But so for photogrammetry, usually the wide camera is what you are using. Next, for the altitude, you can choose to set the altitude either through GSD, which simply means what resolution images you want to capture, or through the flight height. And in this case, at least to me, flight height is a bit more intuitive. I just say, okay, I want to fly at 50 meters, and the flight height will be at 50 meters. More simple, right? Next is the flight speed. So again, depending on what drone you're using, flight speed obviously will be different depending on the application. The default value here is 5 meters. If you have a drone that has mechanical shutter on the camera, so then of course you can fly also faster. But let's say with mini drones, when you're doing some capture, you can fly the default speed of 5 meters, but then when you're doing the data processing, so then you would need to do probably some rolling shutter compensation. And this is, I believe, available in software like Agisoft Metashape and maybe a few others as well, where you can do that. But one thing actually I want to show you, so in case, because I've been hearing this quite often, so in case you want the drone to stop at each position before taking the photo, there's actually also a way how you can get this done. So then this is actually done here in the advanced tab. And if you see this checkbox, additional waypoints. And so if you select that, then actually UgCS will add a waypoint at every location where the drone will need to take an image. Of course, then based on overlap, the speeds, also the distance will vary. But yeah, so that's one way what you can do if you want the drone to stop. And then let's see here. So for example, flight speed, we can even then set, actually let's do this. So the overlap, forward overlap, I can maybe decrease a bit here, just so it's more easily understandable and you can see the distance between the points better. But again, normally you would be flying without stopping, but in this case, I'll just show you one way how, if you want, and this is more for smaller areas that you want to cover. So if you want the drone to stop at each location before taking an image, so how you do that. So yeah, essentially you select this, and then here also you can set, for example, either set camera by distance, which kind of triggers the camera, throughout these positions, or you can actually set a camera shot at each location, just so that each waypoint, the drone will pause and will take an image. So yeah. Okay, now going back, I'll try to finish all the main parameters that are here. So yeah, there's the flight speed that I already mentioned. Then obviously you have your overlap parameters. So typically for photogrammetry, you would have an overlap of around 80% forward, 80% side, or 80-70, depending on what you prefer. Next, the turn type. So usually you'll be flying with adaptive bank turn. So adaptive bank turn will simply allow the drone to fly without stopping, and thus saving battery power, allowing you to scan larger areas. Next, also what we can do, I'll show you here in GCS, there's the elevation profile. So this is up here in the top bar. So if we click on that, then you see, so the elevation profile window will open up. And you can resize this, you can expand this. Recently we added the possibility to have these sort of vertical lines, so vertical line for each waypoint that's here. And so here you can see that UgCS by default, it follows the terrain already automatically. So the default altitude mode is this the smart AGL, but there are different altitude modes that you can select. So now let's just quickly go through them. So starting off, the base one is the AGL altitude mode. So AGL, simply put, it puts a waypoint at each location above the terrain at a certain level, and then if terrain changes by more than a certain number of meters, it will add another waypoint. That's why, for example, here you can see there's this waypoint here in the middle because there the terrain dropped more than this sort of threshold. And then at the ends, of course, there's waypoints just to make the drone turn around. And we can see here there are 79 waypoints in this mission. In case you want to increase the waypoint count and make the drone fly closer to the terrain, so basically to follow it more, to give you one example, you can see here, if you look at the terrain that's underneath the cursor, so you can see that the terrain actually has a slight bump, but the flight path doesn't. So the flight path simply, glides over it to save battery and to, not move the drone around too much. But so one really cool thing that UgCS allows you to do is it allows you to adjust the resolution of the terrain following, if that makes sense. So this is actually done in the advanced tab that's here and through the parameter called AGL tolerance. So by default, the AGL tolerance parameter is set to 3 meters. This practically what this means is that if the terrain changes by more than 3 meters, then UgCS will add a waypoint to ensure that the drone will follow the terrain there. It's that simple. But if you want the drone to follow the terrain more closely, then you can set this to 1, for example. And now you can see that the amount of waypoints has, basically already doubled. So now there's more waypoints here. Drone will change the altitude a bit more. This type of route is slightly more inefficient on the battery. So, as you probably understand, the more waypoints, more adjustments the drone has to do, more battery gets used, right? Makes sense. But you can also do the other way. So if you want the drone to actually, not change its altitude as much based on terrain changes, so then you can increase this value. So for example, you can set the AGL tolerance to something like 5 meters. And now you can see you have less waypoints, so the drone will not be adjusting the flight path that much. And yeah, so it's that simple, and that's sort of what you can adjust with this parameter. But I'd suggest keeping it at something like 3 meters. But if you're flying over terrain where the terrain itself is changing quite rapidly, then it could be a good idea to set this to a slightly lower value. Since nowadays, actually, most drones, they can accept quite a lot of waypoints. I don't think there's I remember at some point there was a limit of 99 waypoints on DJI drones, but now already this has been dropped. So yeah, you can load more waypoints in and basically use more higher resolution terrain following, which in turn results that the overlap between the images of the mapping mission or the photogrammetry mission, this will be more consistent. So this is sort of how to plan a very basic photogrammetry mission. And so now I'll maybe try to also show to you how you can plan a photogrammetry mission that also allows you to capture 3D models, because also I think this is quite interesting, and you'll see a 3D model actually later in this webinar. So I suggest you, if possible, stay, listen a bit more, and also I'll show that to you in a bit. So for example, we see, okay, this small village, so I think this is somewhere in Italy. So let's go ahead and create a new photogrammetry mission. Again, I'll select the Mavic 3 Enterprise, but based on what drone you have, if you'll have the Mini, then a new version, you'll simply select the Mini drone. So again, I'll do photogrammetry, and here I'll try to create a very simple, very sort of straight route. You can see there's 300 meters, so 350 by 200 meters, more or less. In case you see situations like this where some line is not complete, this is because the area is not perfectly rectangular. And so then what you can do, or what I suggest, either you take this point and drag it down a bit, then this small line at the top will disappear, or vice versa. If you want to maybe extend the area a bit, then you can take this point and you can drag it upwards a bit. And then of course the opposite will happen. You'll have one more line over there. So quite simple. Now let's go here into basic parameters. So flight height is still the same, overlaps are still the same. Oh yeah, also by the way, what I kind of forgot to mention on the previous mission is that here under the actions, so UgCS automatically adds the actions for the camera for photogrammetry missions. So you can see the first action we have is set camera attitude, not altitude, attitude. That's important not to mix it up. So it essentially just changes the gimbal angle. That's all it does. So here you can see 90 degrees, meaning the gimbal will rotate the camera 90 degrees downwards. And then set camera by distance, simply to obviously trigger the camera every certain number of meters. That's calculated automatically. If you want to see some more route parameters, what you can do is that here at the top of this route card, you can click on this checkbox that's here, and then this will open up more detailed route log where you can actually see so things such as total size of the area, you can see the footprint, number of waypoints, and you can see for the set camera by distance, so roughly how many shots will the camera take and how often. In this case, it's every 10.5 meters, the camera will snap an image. So, but if you want to not just do normal mapping, but if you want to, for example, create a 3D model of an area, so then what you can do is you can plan an oblique mission. And so with the photogrammetry tool, actually, you can do this very easily, and this will also work with the mini drones as well. So all you have to do is here in the advanced settings, you can turn on this double grid option. And so then what this double grid does is that, as the name implies, it adds another grid on top. So another grid that's perpendicular to the first one. And so as you can see, so then the drone will cover the area from different directions, but that's not all that you have to do. So in addition to that, if you go here under actions, so then where you have this camera angle, so then instead of using 90 degrees for the oblique mission, you would want to use some oblique angle. So for example, you can do something like let's say 70 degrees. So 70, 60, 45, it will depend on the altitude, on the object that you're scanning, and also actually on the amount of trees. For example, I've in the past, when flying over some areas with more trees, I usually go with camera angle that's a bit more facing downwards, so something closer to 70 degrees. I think is so 70, 60. I believe that's the sweet spot. Let's maybe say 65. So yeah, that's how you can plan a double grid photogrammetry mission. So very easy to set up, I would say. And of course, then if you need to make some more adjustments, maybe you want to cover some specific building in more detail. So then of course you can plan this mission specifically around that building like so. So that's one way how you can do oblique photogrammetry, and I'll now try to show you the other way as well, where instead of doing this double grid, you can do the circle-grammetry. So now let's move on to the circle-grammetry. So again, I'll just choose the Mavic 3 Enterprise drone for this example. And then you can see here that on the side, we have the circle-grammetry tool. So let's select that. Let's maybe choose some area over which we want to fly. For example, let's choose this house over here. Or maybe this whole area, actually, we can probably even try to scan. So to do this, you can simply hold down the shift button and then you can mark out the area over which you want to fly. And again, you can see, so this area, it's roughly 300 something by 300 something meters, 330 by 325. So camera again is selected as the wide. By the way, when you see these sort of error messages, don't worry. Like in this case, for example, it's simply because some parameters here are missing. So this is what you might see if you're planning a mission or a specific route type or segment for the very first time. Then later on, once you already have those values in, UgCS will remember all of that, and so they will be saved. So then the flight height, let's set as, since there's no tall trees, looks like, let's set this to, for example, 35 meters. Then the flight speed, we can set at either 5 or maybe even a bit faster. For circle-grammetry, I would maybe do 8 on Mavic 3 Enterprise. But let's say if we're flying with a mini drone, then, for example, let's set this at 5. And then next is the circle radius. So the radius, it will also depend on the height. So how you want to set this. But anyways, usually, so the mini drone specifically will be looking towards the center of the waypoint. So for example, we can set the radius, at least initially, let's set this to 30. And let's see how the mission will look like. So now you see that this is just a combination of circles that are very, very close to each other due to the fact that the circle overlap currently is set to 50. And I would say we can probably decrease this a bit so we can try to do 25 overlap. And already here you can see that this looks a lot more manageable here. Altitude mode is still set at AGL, and the UgCS also, by the way, automatically calculates number of shots per circle. In case you want to see that, you can go here again into the root log, and then it will show you that in this case it will do 18 shots per circle. But if you want to override it, maybe you want to say, okay, I want only 10 shots per circle or something, then you can enter this here. And then the mission will be recalculated with those parameters. If you want to go back, you can just select that, remove, hit enter, and again, it will recalculate the mission. If you want to fly an area with a bit maybe less detalization here, so what you can do is you can either increase the radius, you can also decrease the overlap, and of course then if you want more detalization, so smaller radius, lower altitude, more overlap, and you'll get a more detailed model. But what's interesting is when I have been actually comparing circle-grammetry with normal photogrammetry missions, then in fact usually from smaller set of images, because of this large amount of different angles, I managed to get more or less the same results when processing in Metashape. But yeah, so then here, maybe let's set the radius to, let's actually leave it at 30. Actually, I think for an area like this, probably this is a very sort of good amount of circles, because you also, of course, have to balance out the data quality, together with the flight time. And yeah, so then this is basically how you can plan a very simple circle-grammetry mission, also with UgCS. And also now I'd like to show how you can plan a vertical scan mission. And then after that, we can already go into the next plans that we have for today's webinar. So now let's again create a new route from scratch, and let's again select the DJI Mini 3, DJI Mavic 3 Enterprise drone. And then to plan out the vertical inspection mission, so let's maybe again find some area. Let's maybe say that we want to scan, for example, the front of this house. And then we can go on over to the vertical scan, and let's mark out, for example, that we want to fly here. Of course, this will depend on the building. If you want to capture building from one side or multiple sides, let's say if you want to capture from 2 different sides, then also you can plan it out like so. Okay, let's try to make the drone fly here in the middle. This is just a random area I found on the map. So of course, usually you plan a bit more detailed exactly in that area where you will be flying. So here the minimum height I will set at something like 5 meters. And the maximum height obviously will depend on the height of the building. In this case, let's set this to maybe something like 30 meters, like so. So also in the vertical scan tool, what you can change is you can change, for example, whether you want to scan in a vertical or horizontal pattern. So currently you can see we have the vertical pattern selected, and also we can go here to this drop down and we can select the horizontal pattern instead. The flight speeds also you can adjust. So for example, vertical we can set to 1, horizontal we can set to 5. And also then what's important is you need to know more or less the distance that you will have to the facade. This is usually measured, but to give you an example, so we can go here and then do the distance measurement tool. And then, for example, you can see this sort of wall of the building is here. Obviously, this building is probably lower than what we're now setting, but again, just to give you a bit of an example. So you can see here it's about 3 meters. So normally what I would do is I would take the mission and move. So it's roughly 5 meter distance from the building. So roughly like so. So we would need to move it just a bit more over here. And also what I do oftentimes when I do these vertical missions with UgCS is I sort of try to, in real life, usually there will be, whatever software you use, there will be some slight error in the map itself, usually a few meters. So also I usually try to match up the drone with some, real life sort of, how to say, not place marks, but yeah, some locations on the map. Or ideally, if you place the drone at an exact distance, let's say 5 meters from the building, while the drone is turned on, then also you will be able to put these points. But this method like this also works and will be quite reliable. So now this is the horizontal method, and also we can then set this back to vertical if we want to. So this is just a very simple, very basic vertical mission. And actually, you can, for example, even combine this with some other mission elements. So you can, for example, even in the same flight, you can do a vertical scan, and then you can do either circle-grammetry or let's say double grid photogrammetry from the top. Because one cool thing UgCS allows is it allows you to actually combine different mission segments together. So for example, now I'll just try to very quickly plan out a photogrammetry flight like so over the same area. And even the overlap probably we can slightly increase. Flight height we can decrease to those same, let's say 35 meters. And so already here you can see, so it's now a bit of a mix where you scan the walls of the building and then also you scan at the top. Of course, as you'll see later in the data example, so not always you will be able to automate both. So you might have some situations where, let's say, one wall of the building you can easily automate, so you can have the drone scan it. This will give you consistent overlap and good resulting data. But what you can also do is maybe on some other wall of the building, maybe there's trees or something else that simply prevents you from scanning it. There are also some situations where in case maybe you're scanning some taller, let's say some taller apartment building, you might have some trees around it at the very bottom. So what you can do is in those situations is you can cover certain part of the bottom side of the building manually, just by manually flying the drone and taking pictures. And then from the level of where the trees stop, that's when you can use automation to get more consistent results over there. But yeah, so this is basically how you can also plan vertical emissions for buildings. And now, sort of as one of the final parts of the flight planning workshop, I just also want to show you very quickly how you can plan missions for tower inspections, which also might be quite interesting for many of you, I believe. So again, same process. I'll just create the mission quickly. But now, instead of using normal photogrammetry, actually what I will do is I will select the circle segment. And so now with this selected, we can go to a location where there's some tower. We can, for example, go here. Imagine there's a tower in the middle and then place the circle segment. So when you place it like that, obviously it's just one single circle in which the drone will be facing towards the middle. But if you want to scan a tower from multiple levels, so actually what you can do is you can set the number of laps that the drone has to do and a certain spacing for them. For example, you can see now we have the altitude set at 50 meters, so towers usually are a bit taller. So let's maybe even set this at, let's say, 100 meters. And then we can also choose how many laps we want to do. So for example, let's say we want to do 8 laps with 5 meter spacing, and the direction will be facing downwards. And yeah, that's it. So basically you see we now have not exactly a spiral, but basically a set of circles where the drone starts from the top and then gradually moves to the circles that are beneath it. Here, one thing you'll need to do for the camera though, is so you can see the point of interest will be set here, but if you want to also add the camera action, so then you can do that. You can add this set camera by distance, and then for example, you can set this to, let's say, actually, let's do set camera by time. I think in this case makes a bit more sense. So let's add set camera by time. And for example, every 3 seconds or so, you can have the drone take an image. And this is one way how you can scan towers like that. Yeah, and that's essentially it, how you can plan these very simple missions. And yeah, already then using this, you can do things such as mapping, photogrammetry, creation of 3D models, tower inspections, building inspections. So this opens up a lot of doors for you in the drone pilot career. And then of course, later down the road, in case you decide maybe upgrade to some other, larger drone platform, then also UgCS supports that. For example, missions with magnetometers, ground penetrating radars, LiDAR, and so on. So all of this is sort of within this, let's call it, realm of opportunity that you can do with the software. And also, by the way, one, I'd say quite important part is this map layers window that you can open up from the top bar here. And then also here you can add different map layers. You can change the base map. For example, let's change this to Bing base map here. You can import 2D objects from KML, place marks, you can set no-fly zones, and you can also load maps for offline use. So also everything here is very customizable and allows you to adjust the software to work exactly in the way that you want it to work. And yeah, that's actually for UgCS. That's all. Now I want to show you a dataset sample that was actually collected using the Mini 4 Pro drone. and it was processed using what's called Gaussian splatting. So this wasn't standard photogrammetry processing. This was done with Gaussian splatting. So I'll try to share the screen. This. Okay, there we go. So yeah, you should have it on the screen now. So this model, it's by the way, disclaimer. So this isn't perfect model. So this because in some parts of it there are trees quite nearby, and so yeah, actually you will probably see that some parts are maybe a bit incomplete simply because what we did is we covered the area from a higher altitude using the double grid photogrammetry. And then after that, so to be able to manually capture all these parts of the facade, because there were a lot of trees around, so I simply had to fly manually to capture the facade itself and a lot of details on the building. So yeah, the processing itself, so this isn't your standard photogrammetry. So basically the workflow was doing the image alignment in a reality scan software. And then, so this software you see here, was what was used for Gaussian splatting. This is called post-shot software by a company called UgCS. So yeah, basically here you can see this was all gathered using the Mini 4 Pro drone. As you can see, so this is basically an abandoned Orthodox church. It's located in Latvia, in Suntaži. So a village a bit outside the capital, Riga. And yeah, so here you can see this is, again, like I mentioned, all gathered using Mini 4 Pro. You can see some details, such as, let's say, this is one of the church towers that has fallen over time. I'm not sure since what year this church is abandoned. I think that probably for already quite a while, as you can see from the missing roof. But yeah, so even with the drones such as the Mini 4 Pro, you can see you can capture quite a lot of details from this, especially as long as you ensure to cover a lot of different angles when you do these inspections, then yeah, the result you can get is actually quite good, quite usable, and this can be used for various different applications. And it's not only, I would say it's not only limited to, your professional surveying and photogrammetry and so on. So this can also even be used for visual effects. This can be used for, recreating certain buildings in 3D, which I know, for example, there's some companies who do this to then provide virtual tours, or let's say you can scan some historic castles and then, have basically allow these virtual tours where people can walk through them. So yeah, there's different examples of what you can do, and I think quite interesting. And I think especially with the Gaussian splatting, it's also quite impressive what results you can get. And this is one data set, and I might actually have another one. In case you're following us on YouTube, so on YouTube, if you search for UgCS, you'll be able to find our channel. So this data, this wasn't captured with the Mini drone. This was done with the Mavic 3 Enterprise drone. But what's interesting is also this is Gaussian splatting in this location. This is a laser tag polygon, where you can go play laser tag. Yeah, what's interesting is that this was also flown from, I believe, around 35 meters or so altitude using circle-grammetry with UgCS, by the way. And so here also you can see, especially if you focus on details of all this geometry, the structures that are here, I'd say I was really impressed when I compared the results of standard photogrammetry with Gaussian splatting, because you can, for example, here zoom in on the towers and all the details here. And so, yeah, you can see how I don't have the two models now side by side, but for example, in the standard photogrammetry model, you can't, the towers, they're a bit, they're not as detailed, and also they're missing some parts. But here actually, so you can see all the parts are there, and it's very, very detailed. Processing a model like this took, I think, about a day just to keep the computer on and have it processing. But this was done with a bit higher resolution settings. So processing with a bit lower res settings, this is actually even quite fast and can be done in a few hours. So yeah, that's one of the methods that you can use, and that's sort of the data that you can get. And I believe that if we would fly over this location with the Mini 4 Pro, then actually the results probably wouldn't be that far off, especially if you configure all the flight parameters correctly. So yeah, I'd say this is already quite quite good. But yeah, that's actually what I wanted to show to you regarding the process data sets. So basically two of them. And now I'll stop the screen share of this. We can jump back into the presentation. So just a moment. Okay, there we go. And yeah, so now about the special offer that we have. So, by the way, sorry that again, I guess the monitor is a bit bright. It got a bit darker in the room, so hopefully that's fine. Maybe I'll try to lower the brightness a bit. Okay, let's try like that. So yeah, then basically after the workshop, so now we have a special offer for today's webinar visitors. So for all of you guys, so this is only valid for 24 hours, but so in case you're interested in buying UgCS license, so then for the next 24 hours after this webinar, we have 20% off for all of our UgCS perpetual licenses and subscriptions, monthly subscriptions. So if you go to our website, so to our web shop, which is shop.ugcs.com, then you can purchase any perpetual license or any UgCS subscription with the 20% discount. And for subscriptions, this discount applies for the first 12 months. So not just the first payment, but for the first 12 months, every single month, you'll have the 20% discount. So in case you're interested, you can go on and grab the licenses. This offer expires tomorrow. So basically in 24 hours from now, more or less. So yeah, for those of you who maybe have already been considering buying UgCS, maybe this is a good chance to do that. But anyway, so now, and again, code webinar20, just so it doesn't, we don't forget that. So enter the code webinar20 and you will get that discount. And so now, yeah, basically we can go on in the Q&A section. And in case you have any questions, please put them in the Q&A. I'll keep this slide open for now, just so you can see the code. So because I guess maybe some people might forget about it. So yeah, I'll see what questions we have. I saw that actually my colleagues have answered quite a few. So I see this session has been quite active and quite a lot of questions have been asked. So, okay, so can you talk briefly about Gaussian splatting? Is it a method or specific setting in software? Yeah, sure, I can talk a bit about this. So, so basically Gaussian splatting, it's a different method of data processing. So for standard photogrammetry, basically when it processes the data, what happens is it creates a mesh. And so then on this mesh, you can place textures and so on. If somebody here is a super high specialist in photogrammetry, I might be wrong on this. So on very like deep technical terms. So, but that's essentially what happens, right? So whatever processing software you use for photogrammetry, it calculates the model based on the mesh. So essentially some sort of wireframe gets made. What's different with Gaussian splatting is that it creates the model not based on a mesh, but based on what's called splats. And so splats, think of it like a line. Imagine if you were a painter, but in a 3D space, right? And then you draw a very short line, very long line, whatever you have. So it's basically called a splat. So a line with some color in 3D space. And so when you're processing data sets like that, so firstly, you need to do some image alignment. And then once you have those images aligned, then you can put it in the Gaussian splatting, the processing software that does support Gaussian splatting. And then it calculates the splats, how it's called. In that model that you saw, that I was showing off the field, I'll quickly try to go back there. So here, this one, I think. So now I can see it on the screen. So basically, for this model, around 20 million splats were calculated. And so yeah, if you go into some of these, you can actually see what I'm talking about. So basically, all of these, they are splats. So essentially, I like to think of them as like small brush strokes. And what's really good with this method of processing is that the model looks a lot more realistic. So of course, yeah, if you zoom in super deep, you might not, at least in this case, since this was flown from an altitude, you don't see maybe that much detail there. But especially when you fly closer, or maybe even in the previous model that was showing off the church, also same method was used. And yeah, so for example, for things such as trees, tree branches. So all of this looks a lot more realistic when processed using Gaussian splatting. And so where UgCS comes in there is that actually it's a bit agnostic in the sense of what processing method you use afterwards. So in this workflow, UgCS is simply used to be able to allow you to collect this 3D data. So basically oblique images from the drone. And then these images you can align in software like Reality Scan, and then you can already process them. And either maybe you want to create a normal model, 2D map, 3D model, or Gaussian model made using Gaussian splatting. So then sort of the doors are open, so to say. So let's see what else. Yeah, so the question also about the special offer and the discounts. So yeah, currently, actually the discounts, they are only for perpetual license and for the subscriptions. So these are the current, at least for the webinar offer. So another question from John. So to try out UgCS Open, I need to add a DJI RC N2 and 3 controller and an Android device. Yes. So if you have the Mini 4 Pro drone, that's what you would need. But you can actually download UgCS Open already now if you want to, just play around with it, get more used to it. I'll try to maybe show the web browser again. So to get to UgCS, actually, yeah, you don't need to pay anything. So what you can do, you can simply go to our site, so ugcs.com, which will guide you to this SPH or our SPH engineering site. And then you can head on over to downloads. Then you have UgCS, and then you can simply download. Once you install it, it will guide you through the registration process for UgCS Open, but it's just as simple as confirming your email via confirmation code, and then you will be able to use UgCS Open, plan all your missions, and so on. But yeah, so this is the version where we do not yet have the Mini 4 Pro support. So the support we plan to release next week with version 5.14. But already today, what you can do is you can download this version, you can get started with flight planning, and then next week you'll be able to simply update this version to the newest one. All of your flight plans will stay, so you can already get started with this. Another question. So what alternative software or method would you recommend for orthomosaicing photogrammetry images if I prefer not to use DJI Terra? Okay, so if you're looking for some good software for processing data, I can basically recommend two options. One is Reality Scan software for photogrammetry, also quite good, and now it's even available for free for companies where, if I'm not mistaken, where the annual revenue is less than 1 million. Then you can just download the Reality Scan for free, use it, and yeah, you can make 3D models, you can make maps, so it's quite good, and I would highly recommend. And another option is Agisoft Metashape. Metashape, it is paid software. I think they also have a few plans, but it's very, very good also in the realm of photogrammetry. So if you don't want to use DJI Terra, you can just use directly Agisoft Metashape. By the way, I'm not getting sponsored or we're not getting paid anything by them. It's just software that I have had personal experience with that, and I know other people in our company also use, for demonstrating to customers. So yeah, this is something that I can recommend. Yeah, another question I see. So will UgCS support DJI Mini 5 Pro? So hopefully yes. From our side, we are ready to support it. Basically, we're waiting whether it will be added to DJI's MSDK, because at least currently it's not yet available there. Okay, so can the companion app run on the DJI RC of the Mini 4? Yeah, so I mentioned this a bit earlier in the presentation. So yeah, basically, if you have the Mini 4 Pro drone with the RC2, the one with the screen, unfortunately, you cannot run the companion app there. So it's just DJI's restriction. They don't allow third-party apps. So even Litchi, you can't really install on this controller. There is a workaround. If you have this controller, don't want to buy the other one, it's unofficial, so might work, might not work. We can't officially support it, but I know that on the DJI Fly app, it's possible that you can create a mission there, and it gets saved on the controller's memory as a KMZ file. So it's a bit technical to get it to work, but basically you can. I'll maybe switch the screen share to UgCS here. So basically, what you can do if you don't want to buy the controller without the screen and maybe you don't have Android device. So then any route that you plan inside of UgCS, you can actually export it. So let's click here on export, and you can see you have different formats, and you can export to DJI Pilot 2 format. Obviously, the Mini 4 Pro doesn't support Pilot 2, but what will happen is this will export it to a DJI compatible KMZ file, and that's the key here. And then you can take that KMZ file and you can replace that existing flight plan on the internal memory of that DJI controller. But again, just maybe reiterate a bit. So it's an unofficial way that you can try to see if you can get it to work, but we do not officially support this way. So if you have some technical problems with specifically this method, we won't be able to help you, unfortunately. But I know some people have had success with this. I know this can work. So if you have some technical skills, some technical background, and you're just interested maybe in tinkering a bit with this, so it is possible to also get it to work with the inbuilt display screen. Okay, so another question regarding Mavic 3 Enterprise. So is it possible to shoot RAW even with slower flight speeds? I haven't had super much experience with especially capturing raw images. I know that basically how it would work from a UgCS perspective. So we don't really restrict so what formats and so on you are capturing. That's all done on the DJI Pilot 2 side for the Mavic 3 Enterprise. So basically for UgCS, you would simply have the mission planned. So let's say maybe you have, this is the mission you want to capture. And then on the drone side, you would on DJI Pilot 2 app, you would configure so what format images should it capture. So that's essentially how it would work. And then, of course, you can set whatever flight speed you want on the drone to get it to capture the images. So another question. So sometimes in the field, I need to change the flight parameters such as the area, flight height, and more. Is it possible to alter these settings after uploading the mission to the DJI drone? Okay, so here the answer is no. So that after you upload the mission to the drone, that flight plan is already on the drone. So to be able to change it, what you would need to do is you would need to modify the mission itself and then re-upload it to the drone. So yeah, you can't really modify in real time. Only thing you can do with DJI drones, and this is a thing a lot of people I think don't really know about. Let's say you launch your drone on some, for example, photogrammetry mission. So where we had it here. So let's say you launch the drone on photogrammetry mission and you realize, okay, the drone is flying a bit too slow, or maybe you want to speed up some parts of it, or yeah, maybe you see there's like some obstacles that coming up and you want to just slow it down a bit. What you can do is while the drone is on automatic mission, you can use the throttle stick of the RC, and this will slow the drone down or speed the drone up. This 100% I know it works. I can't guarantee this will work with every single DJI drone, but most DJI drones, this will work. So M300, Mavic 3 Enterprise, Phantom 4, and many others. With the Mini, I believe also it's the same, that it will work. So if you speed it up or slow it down. What you cannot do in real time is you cannot alter the flight trajectory. So you can change the speed with throttle stick, but you can't, for example, suddenly say, okay, I want the drone to suddenly fly the same mission, but 10 meters higher, and I want to change this in real time. What you can do in those situations where, let's say, maybe you have flown some part of the mission and you want to fly a bit higher, want to change some parameters, but maybe you don't want to really re-upload. So what you can do is you can take the same mission, you can duplicate it in UgCS. And so this one, let's hide. And then basically for the new mission, let's change something. Let's say the flight height to 60. And then basically what you will do is if you have a drone that can be directly connected to UgCS, then sort of this is what you will see more or less. So you'll see these commands. And then when you upload the route to the drone, you can choose actually from which waypoint you want to start. So let's say if maybe you want to start from here, so from waypoint number 85, then after you press on upload, then there will be a window where you can input that exact number and the route will re-upload from that point. So that's what you can do if you want to change some parameters. Also, by the way, I know some of our customers, if they don't want to take a laptop in the field, but they know, okay, I might need to do some mission changes, what you can also do is Windows tablet, for example, or something like that. Even recently, I a bit experimented with connecting from my Android phone remotely to my computer, changing the mission there, and this is also one way that can work. But again, that method is a bit maybe unofficial, but yeah, so there's different ways how you can alter your mission and then re-upload it to the drone. Okay, another question from Greg. So can license be transferred between computers, Office PC to field PC? So by default, so each license has one activation when you buy it, but it's possible to buy an additional device. So on our shop, you can get an additional device for your license. So because I know some people, they just have one computer, but in case you have two separate computers, you want software on both, then you don't need to buy two licenses. You can just buy one license and then you can just buy this additional device package. Okay, so let's see what else. Okay, yeah. So from Robert, there's this question also about this discount offer that we have. I'll just quickly reshare this again. So regarding the timing, yes. So here I mentioned when exactly does the offer expire. So in case maybe it wasn't clear. So the offer expires tomorrow, October 2nd. At 7 Eastern European Summer Time. Well, this time because we are located in Riga. So yeah, basically 24 hours from now, this is when the offer will expire. So for now, it's active. So if you want to go grab your license or the subscription for UgCS, then you can do that now. Okay, and I think actually with that, those are all the questions that we had. Since there's no more questions, I think we can probably then wrap it up for today. So yeah, all I want to say is thank you guys for expressing your interest in UgCS software. So I hope this webinar was interesting for you. Hope you learned something. Yeah, so in case maybe some of your questions didn't get answered, we'll try to reach out to you, or you can also ask the question on the Facebook group or reach out to us at support@ugcs.com. I'll maybe put it on the screen here. So yeah, we're trying to answer all the questions we can, but of course something always goes unanswered. So yeah, basically here, support@ugcs.com. So if you have some technical question or need help with something, or even have a more sales-oriented question, you can send an email to support@ugcs.com and we'll get back to you and we'll talk with you. So, and also you can, if you want to reach out to me directly, you can also do so either through this email or through my LinkedIn.